Dante AV networking has become very important in modern audiovisual systems. It allows us to send high-quality audio and video over standard computer networks. This technology uses IP, or Internet Protocol, packets to transmit AV signals. This means you can use existing network infrastructure, like switches and cables that many buildings already have. The flexibility offered by Dante AV is a major advantage. You can easily route signals from any source device to any destination device on the network. This simplifies complex AV setups considerably, making installations quicker and more adaptable to changing needs in various environments, such as live events, corporate offices, and educational institutions. The importance of Dante AV lies in its ability to streamline AV installations. Traditional AV systems often require many different types of cables for audio, video, and control. This can lead to a lot of clutter and complexity. Dante AV reduces this by using a single network cable, typically Cat5e or Cat6. This not only makes installations cleaner, but also more cost-effective in the long run. Furthermore, Dante AV supports uncompressed multi-channel audio and high-definition video with very low latency. This ensures that the quality of the AV signals remains high, which is crucial for professional applications where performance cannot be compromised. Another key benefit of Dante AV is its scalability. You can start with a small system and easily expand it as your needs grow. Adding new devices to a Dante AV network is straightforward. You just connect them to the network and use software to configure the signal routing. This scalability makes Dante AV suitable for a wide range of applications. From small meeting rooms with a few devices to large university campuses or stadiums with hundreds of AV endpoints, the system can adapt. This ability to grow with an organization's requirements is a significant factor in its widespread adoption across different industries. Dante AV also integrates well with IT infrastructure. Since it uses standard networking technology, IT departments can often manage the network. This convergence of AV and IT is a growing trend. It brings benefits like centralized management and improved security. However, it also means that AV professionals need to understand networking principles. This understanding is vital for designing, implementing, and troubleshooting Dante AV systems effectively. Having a robust monitoring system like a well-designed dashboard becomes essential to maintain the performance and reliability that users expect from these advanced AV solutions, ensuring smooth operations. Monitoring Dante devices is the first critical aspect. Your dashboard needs to show all connected Dante AV equipment. This includes microphones, mixers, amplifiers, speakers, video cameras, and displays. For each device, you should see its status online, offline, or in an error state. Knowing the IP address and firmware version of each device is also very useful for management and troubleshooting. If a device goes offline, the dashboard should immediately flag it. This allows technicians to quickly identify and address the problem, minimizing downtime in a live event or critical presentation, where every second counts for a seamless experience. Clock master status is another vital element to monitor closely. In a Dante network, one device acts as the PTP, or Precision Time Protocol, clock master. All other devices synchronize their clocks to this master. If the clock synchronization is lost or unstable, you can experience audio dropouts, clicks, pops, or video glitches. The dashboard must clearly indicate which device is the current clock master. It should also show the status of clock synchronization for all other devices. Any changes in the master clock or synchronization errors need to be highlighted prominently so that they can be investigated and resolved without delay. Monitoring multicast flows is crucial, especially in larger Dante AV networks. Dante uses multicast to send audio and video streams to multiple destinations simultaneously. While efficient, unmanaged multicast traffic can flood a network if not configured correctly. Your dashboard should display all active multicast flows. It should show the source device, the destination devices, or at least the multicast group address, and the bandwidth being used by each flow. This information helps in understanding network traffic patterns. It also helps in identifying any unauthorized or problematic flows that might be consuming excessive bandwidth or causing congestion on the network infrastructure. Finally, latency and jitter are key performance indicators for Dante AV. Latency is the delay it takes for a signal to travel from source to destination. Jitter is the variation in packet arrival times. High latency or jitter can severely impact the quality of audio and video, leading to lip sync issues or distorted sound. The dashboard should provide real-time monitoring of latency and jitter for critical paths in the network. A heat map or graphical representation can be very effective for visualizing these metrics. Setting thresholds for acceptable latency and jitter and alerting when these are exceeded is essential for maintaining a high-quality user experience across all connected AV endpoints. A well-designed Dante AV dashboard needs a clear and intuitive layout. The main overview page should provide a high-level summary of the entire network's health. This could include a count of online and offline devices, overall clock status, and any active critical alerts. From this overview, users should be able to drill down into more detailed sections. The layout should be logical, grouping related information together. For instance, all clock-related information could be in one dedicated panel. The goal is to allow an operator to quickly assess the system's status and pinpoint any issues without being overwhelmed by too much data at once. One essential section is the clock status panel. This panel should prominently display the current primary clock master device. It should also show the backup or secondary clock master if one is designated. The status of synchronization for all slave devices needs to be clearly visible, perhaps using color codes: green for synchronized, yellow for syncing, and red for error. Any clocking errors, such as a lost master or multiple devices attempting to be master, should trigger an immediate visual alert in this panel. Details like the PTP version in use and the Grandmaster ID can also be included for advanced troubleshooting scenarios. The device matrix view is another crucial section. This provides a visual representation of all Dante devices on the network. It could be a list or a graphical layout. Each device should show its name, IP address, online status, and basic health indicators. Clicking on a device in this view should bring up more detailed information. This might include its current subscriptions or audio and video flows it's receiving or sending, firmware version, and any specific error messages. This matrix allows for quick identification of problematic devices and provides a central point for device management tasks, such as rebooting or reconfiguring a unit remotely. Flow, monitoring, and latency heat map sections are vital for performance analysis. The flow monitoring section should list all active audio and video flows. Information displayed should include the transmitting device, receiving device or devices, channel count, bandwidth usage, and flow status, like active or interrupted. The latency heat map provides a visual representation of latency across different paths in the network. It can use colors to indicate latency levels, making it easy to spot areas with high delay. This helps in identifying bottlenecks or misconfigured devices that might be introducing unwanted delays, ensuring that the AV experience remains smooth and synchronized for all users. A robust network structure is fundamental for reliable Dante AV operation. Proper switch selection is the first step. Managed switches are highly recommended over unmanaged switches. This is because managed switches offer features essential for Dante AV, such as quality of service or QoS and IGMP snooping. QoS allows you to prioritize Dante clocking and audio or video traffic over less critical data. This ensures that time-sensitive AV packets are not delayed or dropped, especially on networks that carry other types of traffic. Look for switches with sufficient port density, PoE, or power over Ethernet if needed for devices, and enough backplane capacity to handle the expected traffic load. VLAN, or Virtual Local Area Network, set up as a best practice for Dante AV networks. VLANs allow you to segment your network. You can create a separate virtual network specifically for Dante traffic. This isolates AV traffic from other data, like general office internet traffic or control signals. Isolation improves security and performance. It prevents non-AV traffic from interfering with Dante flows. It also makes network management easier. For example, you could have one VLAN for Dante primary audio, another for Dante secondary audio if using redundancy, and a separate one for control traffic, keeping everything organized and efficient. IGMP, or Internet Group Management Protocol. Snooping is crucial for managing multicast traffic. Dante AV uses multicast to send a single audio or video stream to multiple devices simultaneously. Without IGMP snooping, multicast traffic is treated like broadcast traffic. This means it gets sent to all ports on the switch, even those connected to devices that don't need the stream. This can flood the network and overwhelm devices. IGMP snooping allows the switch to learn which ports need which multicast streams. The switch then only forwards multicast traffic to the ports that have requested it, significantly reducing unnecessary network load. Switch configurations must be done carefully. Beyond QoS and IGMP snooping, ensure that energy-efficient Ethernet, also known as green Ethernet, is disabled on ports used for Dante. EEE can sometimes cause Dante devices to lose sync or drop audio packets because it tries to save power by putting ports into a low-power state. Spanning Tree Protocol, or STP, settings should also be reviewed, though modern Dante systems are generally compatible with standard STP configurations. Always refer to the Dante manufacturer's guidelines and the switch vendor's documentation for specific configuration recommendations to ensure optimal performance and stability of your AV network. Section 5. Ensuring uptime redundancy in Dante AV networks. Redundancy is key to ensuring the continuous operation of Dante AV systems, especially in critical applications. Many Dante devices support a redundant network connection. This means they have two network ports, a primary and a secondary. You can connect these ports to two separate, independent networks. If the primary network fails due to a switch malfunction, cable damage, or other issues, the Dante devices automatically switch to the secondary network. This switchover is designed to be seamless with no interruption to the audio or video signal. Implementing this dual network architecture significantly enhances system reliability. To achieve true redundancy, the primary and secondary networks must be physically isolated. This means using separate switches, separate cabling, and potentially even separate power sources for the network equipment in each path. If both networks share a common point of failure, such as a single power supply for all switches, then the redundancy is compromised. The goal is to eliminate any single point of failure that could take down both networks simultaneously. Careful planning of the physical infrastructure is therefore essential when designing a redundant Dante AV system to maximize its resilience against unforeseen problems. Using redundant switches is a core part of this strategy. For the primary network, you would have a set of switches. For the secondary network, you would have an identical, or at least functionally equivalent, set of switches. Devices with primary Dante ports connect to the primary switches, and their secondary Dante ports connect to the secondary switches. This ensures that if an entire switch fails on the primary network, traffic can still flow through the secondary network via its dedicated switches. This approach provides a robust safety net against hardware failures within the network infrastructure itself. Beyond network port redundancy, consider power redundancy for critical network components. Switches, servers running Dante Domain Manager and other essential infrastructure should ideally be connected to uninterruptible power supplies, or UPS. In larger installations, dual power supplies in switches connected to different power circuits can provide an even higher level of power redundancy. The dashboard should also monitor the status of redundant links and power supplies. Alerts should be generated if a redundant path fails, even if the system is still operational on the alternate path, so that the fault can be rectified before it impacts overall system availability. Section 6. Visualizing success, a mock-up of the Dante AV dashboard. Imagine a Dante AV dashboard designed for clarity and quick action. The main screen would greet the operator with a system health overview. This section uses large, easy-to-read indicators, a green checkmark for all systems nominal, a yellow triangle for warning minor issue detected, or a red cross for critical alert action required. Below this, key metrics are displayed as gauges or simple numbers. Total devices online, offline, clockmaster status, and active multicast flows count. This immediate visual feedback allows anyone, even with minimal training, to understand the network's current state at a glance. A prominent section would be the device status matrix. This could be a grid or a dynamic list. Each row represents a Dante device. Columns would show device name, IP address, model, firmware version, online, offline status, and a small sparkline graph showing recent packet loss or latency, if available. Clicking on any device name would open a detailed pop-up window. This pop-up would provide more in-depth information, current subscriptions, clock sync status relative to the master, uptime, and any specific error codes the device is reporting. This allows for rapid drill down from a general overview to specific device diagnostics. Another vital part is the network traffic and flow monitor. This section might use a combination of tables and graphs. A table could list all active audio and video flows with details like source device, destination device, flow name, bandwidth used, and packet error rate. Alongside this, a graph could show total network bandwidth utilization over time, perhaps broken down by primary and secondary networks if redundancy is implemented. Visual cues like color coding flows that are experiencing high error rates or are using unexpectedly high bandwidth would draw attention to potential problems quickly and efficiently. Finally, a latency and jitter heat map offers a powerful visual tool. This could be represented as a matrix where rows are transmitting devices and columns are receiving devices. The color of each cell would indicate the current latency between that pair, ranging from green to red. Hovering over a cell could show the exact latency figure and jitter value. This makes it very easy to spot specific paths or devices that are introducing unacceptable delays. Alerts could be tied to this heat map, highlighting cells that exceed predefined latency thresholds, guiding technicians directly to problem areas within the complex web of AV signals. Section 7. Staying alert. Critical notifications for network health. Implementing critical alerts is essential for proactive Dante AV network management. One of the most fundamental alerts is device offline. If any Dante-enabled device unexpectedly disconnects from the network, an immediate notification should be generated. This alert should include the name of the device, its last known IP address, and the time it went offline. This allows support staff to quickly investigate whether the issue is due to a power failure, a disconnected cable, or a device malfunction. Early detection of offline devices minimizes disruption to AV services, especially during live events or important presentations where every input and output is crucial. Clock synchronization error alerts are equally vital. The stability of the PTP clock master and the synchronization of all slave devices are paramount for Dante performance. Alerts should trigger if the designated clock master goes offline, if multiple devices attempt to become master, or if any device reports a loss of sync or excessive clock drift. The alert should specify the device involved and the nature of the clocking problem. Prompt attention to clocking issues can prevent audible artifacts like clicks, pops, and dropouts, or visual problems like video stutter or signal loss, ensuring a high-quality experience. Alerts for high latency or jitter are critical for maintaining AV quality. While Dante is designed for low latency, network problems or misconfigurations can introduce delays. The dashboard should allow administrators to set thresholds for acceptable latency and jitter on specific flows or device paths. If these thresholds are exceeded, an alert should be triggered. The notification should identify the affected flow or devices and the measured latency jitter values. This helps technicians pinpoint bottlenecks, such as an overloaded switch or a problematic network segment, before users start complaining about lip sync issues or other quality degradation. Network link failure or redundancy path issue alerts are crucial for systems with redundant setups. If a primary network link fails and the system switches to the secondary path, an alert should be generated. Even though the AV service might continue uninterrupted, the system is now operating without its primary safety net. Similarly, if a redundant power supply on a switch fails, it needs to be flagged. These alerts ensure that technicians are aware of any degradation in the redundancy status. This allows them to repair the failed component or link promptly, restoring full redundancy and maintaining the system's overall resilience against future failures. Section 8. Troubleshooting Dante AV, a practical workflow. When a Dante AV issue arises, a systematic troubleshooting workflow is essential. The first step is always to check the dashboard for any active alerts or obvious red flags. Look at the device status matrix. Are all expected devices online? Check the clock status panel. Is the correct device master? And are all other devices synchronized? Review the flow monitoring section. Are the problematic audio or video flows active and showing normal bandwidth? The dashboard provides the initial clues. For instance, if a microphone isn't working, check if the microphone device is online and if its audio flow is correctly routed and active. If the dashboard indicates a device is offline, the next step is physical inspection. Check the device's power supply. Is it powered on? Are the network cables securely connected at both the device end and the switch end? Try a different network cable or a different port on the switch to rule out faulty cabling or a bad switchboard. If the device has status lights, check what they indicate. Sometimes a simple reboot of the problematic device can resolve connectivity issues. Document any physical changes made, as this information can be useful if the problem persists or recurs later on. For issues like audio dropouts, clicks, pops, or video glitches, clocking problems are a common culprit. Use the dashboard to verify clock master status and slave synchronization. If there are clocking errors, identify the source. Is there a rogue master? Is the designated master device stable? In Dante controller software, you can manually set the preferred master clock or investigate PTP event logs if available. Also, check switch configurations. Ensure energy-efficient Ethernet is disabled on Dante ports, and confirm that QoS settings are prioritizing PTP clock traffic correctly across the network. If network performance issues like high latency or packet loss are suspected, use the dashboard's latency heat map and flow monitoring tools. Identify which flows or paths are affected. Check the involved switches for high CPU utilization or port errors. Ensure IGMP snooping is correctly configured and working, preventing multicast floods that could congest the network. You might need to use network analysis tools like Wireshark to capture and analyze traffic on problematic segments. This deeper analysis can reveal issues like packet storms, misconfigured VLANs, or faulty network hardware that the dashboard might only hint at. Section 9 Conclusion. The value of a comprehensive Dante AV dashboard. A well-designed Dante AV networking dashboard offers immense value. It transforms complex network data into easily understandable visual information. This clarity is crucial for managing modern AV systems, which are increasingly reliant on network infrastructure. Instead of sifting through command-line interfaces or individual device web pages, technicians get a centralized overview of the entire Dante AV ecosystem. This significantly speeds up system health checks and status monitoring. The ability to see everything in one place means potential issues can be spotted much earlier, often before they impact the end-user experience in any noticeable way. The dashboard plays a critical role in rapid troubleshooting. When problems do occur, such as a loss of audio, a video signal dropping, or devices disappearing, the dashboard provides immediate insights. Alerts for offline devices, clocking errors, or high latency guide technicians directly to the source of the issue. The detailed views of device status, network flows, and latency metrics provide the necessary data to diagnose problems efficiently. This reduces downtime significantly. In live event production or critical communication environments, minimizing downtime is not just a convenience, it's an operational necessity that a good dashboard helps achieve effectively. Furthermore, a comprehensive dashboard aids in proactive maintenance and network optimization. By monitoring trends in bandwidth, usage, latency, and device health over time, administrators can identify potential bottlenecks or areas for improvement. For example, consistently high traffic on a particular network segment might indicate a need for upgrading switch capacity or re-evaluating flow configurations. The historical data and logging features that often accompany such dashboards are invaluable for capacity planning and for ensuring the network can support future growth and new AV services without performance degradation, thereby future-proofing the investment. In conclusion, investing in the development or deployment of a robust Dante AV networking dashboard is a wise decision. It enhances operational efficiency by simplifying management tasks. It improves system reliability through proactive monitoring and rapid troubleshooting capabilities. It also empowers AV and IT staff with the tools they need to maintain high-quality audio and video delivery. As Dante AV continues to grow in popularity and complexity, a dedicated dashboard becomes less of a luxury and more of an essential component for any organization serious about leveraging the full potential of networked AV technology, ensuring smooth and professional presentations.